We are moving into chapter 4. So as a warm-up today, students just wrote down something they learned in chapter 3. We shared out loud what we learned, so many good things. And now we're moving into lesson 4.1, classifying triangles. Okay, there are 2 ways you can classify triangles. The first way we're going to talk about is by their angle measures. Okay? The second way is by their side lengths. All right, let's start with angle measures. So we have a couple options here, more than a couple, more than a few, 4 options for different types of angle measures that could be inside of a triangle. We could have 3 acute angles as shown. What's an acute angle again, folks? Less than 90 degrees. Yep, less than 90 degrees. So you can see here, I have 3 angles that are all less than 90 degrees. Any guesses what we call that triangle? An acute triangle. Yeah. A cute little triangle. All right, there's one special type of an acute triangle. This one's special. And if it's all 3 of those acute angles are congruent or are the same measure. Let me ask you this question before I classify it. If they are all acute and they're all the same measure, what would their measure be? 60. How'd you know that?
60 plus 60 plus 60.
That's the total what?
Yeah.
Yep, the degrees in a triangle total 180. So 180 divided by 3, if they're all the same, these would all be 60, right? Okay, any guesses what this special acute triangle is called? No, good guess, but no.
Equilateral.
Oh, that's if they're all the same side.
I know one that has finger
I thought this was
It does have equal. That's if they have all the same sides. What do they have equal what?
Equal angle.
Equal angular. Close enough.
Yeah.
Equal angular.
So smart, I got it right.
Equal angular, and it's just a special type of an acute triangle. Okay. Now, we just talked about how the degree measures have to total 180. So if we have an obtuse angle in our triangle, obtuse is greater than 90. There can only ever be one, obviously. Any guesses what that triangle is called? Obtuse triangle. Pretty creative, right?
Now these mathematicians.
Right? All right. And then our last special one, these are probably my favorite, although they're all equally special, especially this one, is if we have a right angle, which measures how many degrees? 90. What do you think you call that?
Right triangle.
You guys are so smart. You're right. A right triangle. I like right triangles because like Pythagorean theorem works, and there's a lot of special relationships with right triangles you can do. We'll get there. Yeah, they're fun.
Easy doesn't
Okay, so that's by angle measures. Now by side. So you guys said equal lateral. That's if we have 3 congruent sides. So that's our first one there. Look at the markings too. They're showing us that all those side measures are the same.
Isn't it equiangular or is it equilateral? Oh, it's sides.
Yep, equilateral, but here's a good point, William, is if they have all equal sides, do you remember what that means about their angles? They're all congruent, yep. So let's just make that note. If all sides are congruent, look at us using a conditional statement, then all angles are also congruent. And that can work in the converse. If you know all the angles are congruent, then all the sides are congruent as well. So that's kind of like another little special relationship with equilateral, equal angular. We call those regular polygons. We actually did talk about those in chapter 1. Okay, Alex, I know you're dying for this one.
This is the only one I can remember because I remember 5th grade, Mr.
Isosceles.
Isosceles. He wants to have
Yep.
his firstborn child named Isosceles, but we all make fun of him because he never even had a girlfriend.
Oh no!
Oh.
He still lives in
Isosceles.
No, he doesn't. He used to live.
Then
where-
who's that old redhead
Okay,
that
now I'm
lives
recording this lesson.
Let's do Isosceles is two congruent sides, right? Isosceles. I struggle with the spelling of that. That's how you spell it. Is if you have at least two congruent sides. Do you remember what no congruent sides is?
Nope, a triangle.
Oh, come on, my 7th grade.
I'm trying to
Really?
Obviously.
Let me
You're
see.
wrong.
I think it's a special word. It's already a class. It's always important.
Scaling.
Scalene.
Oh,
It's a scaling one.
I didn't hear you.
you didn't say.
Okay, so kind of new vocab, but you've seen this before. 2 ways you can classify by sides or by angles. Let's practice a couple problems. First one, classify triangle XYZ as acute equal angular obtuse or right. So they want us to classify it based on its angles. Explain your reasoning. All right, I'm going to highlight triangle because there's lots of triangles kind of in this picture here. I'm going to highlight the one they want me to do, triangle XYZ. Those would be the vertices that outline my triangle. That'd be this triangle right here. That's the one they want me to classify. So looking at the angle of measures, I have 50 degrees, 40 degrees. And using my angle addition postulate, Alejandro, what's the measure of this angle right here?
90 degrees.
90, which makes this a right angle. Which makes this what type of triangle?
Right.
Right triangle, yep. Right triangle. That'll be our classification. Exclamation, the measure of angle XYZ is 90 degrees. Actually, in this drawing, in this lovely diagram, all of these triangles are right triangles. Let's look at this one. Right angle right here. This one, if this is 90 degrees, what would this measure be? Also 90. They're supplementary, so those are all right triangles. Okay. Next, we're going to practice classifying one by the side. So read this next one. It says, if y is the midpoint of Vx, of side Vx in my triangle, and Wy is 3 units, classify triangle VWY as equilateral, isosceles, or scalene. So I see that, and I'm like, okay, that's classifying it by sides. So I'm not looking at the angle measures, I'm looking at the side lengths. Here's what we know. Let's break this down. We know y is the midpoint of Vx. Here's Vx. If y is the midpoint, what does it do to this line segment? Splits it in half. And we know this line segment is 8.4 units. So what's each of these segments? How'd you get that? Right, half of that. It divides it right in half. These would each be 4.2 units. Okay, let's label that. Forward shifted on. Okay. That's what we know from just that first statement. Next, we know Wy is 3 units. Okay, let's label that. Now they want us to classify triangle DWY. Let's talk about this triangle right there. All right, look at the side lengths. What do we notice? Matthew?
None of the sides are the same.
None of the sides are the same length, so it's what type of triangle? Scalene. Okay, it does say we have to explain. So let's just quick show. Oops. We have to do Vy. Vy is 4.2 units. VW is 4.5 units. WY is 3 units. And exactly what Matthew said, no sides are the same, or no sides are congruent. You could say they all have different side length measures. All the sides have different side length measures. But since it has no congruent sides, scalene. Okay, we only have 4 problems left to go. Any questions? Are you having fun?
I can try.
Try to make it exciting. All right. Oh, here we go. Let's throw some algebra in. That'll make it fun. Find the measures of the sides of this isosceles triangle, KLM, with a base that's KL. All right. So they're telling us this triangle is isosceles, which means it has how many congruent sides? 2. And they're telling me that my base is KL. Now, what that tells me, KL is my base here, is that these are my 2 congruent sides. If that's my base, that's like my longest side. And the picture is like drawn to scale there too. But when they say base is KL, the other 2 sides would be the congruent sides. All right, so I need to find the measure of each side, but first I have to algebraically solve for what D is. So I can set up an equation by setting my 2 congruent sides equal to each other. And then I can solve for my variable. All right, I would add over D and get 5D. Then I would add over 13 and get 25. Then I would divide by 5 and get D is 5. It's not what they asked me to find. With me? They asked me to find the measure of each side. So let's see. I'm going to start with, let's do LM. LM's a pretty easy one to calculate. It's just 12 minus D. So 12 minus 5 is 7 units for LM. Without doing any math, what other side length could we identify? You can shout out. KM, right? KM is also what? 7. Those are 2 congruent sides. Could you go ahead and plug in 5 here and do 20 minus 13 and get 7? Yes, you could, but save yourself some time, right? We know those are 2 congruent. KL, however, I'm going to have to do some math there. I know it's D plus 6. So 5 plus 6, I'd get 11 for that one. All right. He finished these problems already. Okay, one more. Find x and the length of each side if triangle RST is an equilateral triangle. Okay, what does that mean, Tyler?
All sides are the same thing.
All sides are the same length. Bing, bing, bing. Good. So when I set up an equation here, you can pick any 2 sides to set equal to each other. It doesn't matter. You're going to get the same answer. I just picked my easier one, so I did like 2x plus 2 is equal to 3x. This is a one-stepper. I just got to move over the 2x, and I get x is 2. How fun. This is like basically one problem. Well, you get 3 side lengths for the price of 1, I guess is what I'm trying to say. So if we just find like ST, for example, which is 3 times x, x is 2. ST is 6 units. So what's RT? 6 units is equilateral. What's RS? 6. They're all 6. Could we go through and do the algebra? Yes, we can, but we know it's equilateral, so all the sides are going to be the same length. In this case, 6 units. Okay, any questions? Okay. 2 more problems to go. Let's step it up a notch. They want us to classify triangle PQR by its sides without drafting. So I want to find the length of the sides. Idea, Tyson. Distance formula. Oh my gosh, great idea. All right, I'm going to start with finding the distance between P and Q. The distance formula would give us the length of all these line segments, all these sides of my triangle. All right, here we go. Oh, it's so cool how math just builds, right? We've been using distance formula since chapter 1. 6 minus negative 1 squared plus 3 minus 2 squared. Okay, I'm going to kind of quickly go through this since it's review. That'd give me 7 squared and 1 squared, which is 49 plus 1. We get the square root of 50. That's obviously not a perfect square. I'm going to write it as a simplified radical because it's good practice. If you want to write it as a decimal, that's fine, but just know on my answer key I'm going to have simplified radical. So 25 is a perfect square that goes in to 50, so it's 5 root 2, or you can get the decimal if you want, but that's the length of that side, PQ. Okay. Now let's find QR. Doesn't matter what order you do this in. Okay, what's the side length of QR? We have, let's go 6 minus 0 plus, if I do it in that order, I gotta do 3 minus 0. You see, I get 6 squared, 3 squared. So I'm getting 36 plus 9. Square root of 45. 9 is a factor of 45, so that'd be 3 root 5. Hopefully we're getting a little better simplifying radicals. All right, so automatically we know it's not what type of triangle? Equilateral, right? We know that these sides are different, so it can't be equilateral. It could still be isosceles if we do PR and one of them is the same length as either PQ or QR. All right, let's keep going, but we know already it cannot be equilateral because those two sides are different lengths. All right, PR, last one. Negative 1 minus 0 squared plus 2 minus 0 squared. We get negative 1 squared plus 2 squared. We get 1 plus 4. We get the square root of 5. All right, so we obviously have distances between our vertices that are all different side lengths. So what's our triangle? Scalene. Okay, we have one more to do. That's all. I think I have it at the bottom of this side. There we go. Triangle MNP is isosceles with side MN congruent to side NP. MN is 2 less than 5 times x. NP is 7 more than 2 times x. And PM is 2 more than 3 times x. Find x and the measure of each side. Holy guacamole, that's a lot of info. Let's draw a picture. Isosceles triangle. Okay, your picture doesn't have to be perfect, but try to maybe make, 2 side lengths that are about the same length. That might be a little bit long there. In your triangle. Okay, so MN is congruent to NP. So the vertice they share is N. So let's call this one MN and this one NP. That would work. All right. MN is 2 less than 5 times x. All right, well, 5 times x would be 5x. And 2 less than that would be minus 2. Let's label that. NP, if I keep reading here, NP is 7 more than 2 times x. Okay, well, 2 times x, 7 more than that, plus 7. Lastly, PM is 2 more than 3 times x. 3 times x, 2 more than that, plus 2. All right, how would I set up an equation to solve for x? William?
5x minus 2 equals 2x plus 7.
Perfect. Those are my 2 congruent sides. So I'm going to set those equal to each other. Good job. Solve this. Subtract over the 2x. Add over the 2. Divide by 3. we get x to be 3. Okay, we found x. Now we just have to find the measure of each side. All right, I'm going to do mn. Doesn't matter which one you do. Mn is 5 times x minus 2. 15 minus 2 is 13. Which means NP is also what? 13? Okay, and then lastly to find MP, we just gotta plug her in. 3 times x plus 2. 3 times 3 is 9, plus 2 is 11 units.
Okay.
That's it. Great, that's a great kind of like first chapter lesson. All right, I'm gonna pass out the 4-1 worksheet. Stop it for you, Fred. Okay. What question about